Hey everybody. So usually my videos focus on the 7th grade standards for Indiana. As you can see, this video is on a couple of the 8th grade standards. My advanced 7th grade class in the second semester, I start incorporating, that's a new word today. I start incorporating some of the 8th grade standards. So that's what this is for. Today we're going to be solving equations with variables on both sides of the equal sign. So the goal on this is to get your variables together on one side. Some people prefer that their variable always be on the left. For me, it doesn't matter. I try to avoid negatives at all costs because that tends to be where you have the most common silly little mistakes. But as long as you've got your variables on one side and your constants, your normal numbers together on the other side, then it all works out in the end. So let's check out this first problem here. I have 7y minus 8 equals 6y plus 1. We've got to get those variables together. So I can either subtract 7y from both sides. That'll make it drop out on the left, but that's going to give me a negative on the right. It's okay, but I'd rather keep it positive if I could. So I'm going to go with the second option, which is subtracting the 6y from each side. If it helps you, I would encourage you to split through the equal sign. Just kind of makes the two sides more obvious to your eyes. So I am going to subtract 6y over here and subtract 6y over here. You want to keep it balanced. Don't tip your teeter-totter. On the left side, 7y minus 6y is 1y. I still have minus 8 equals. On the right side, those y's cancel. And I just have a positive 1. You don't have to put plus 1. You can just put 1. Now I've got to get my constants together. What I've really created here is a two-step equation. So I need to get rid of what's with the variable, but not directly touching it. I want to get rid of that minus 8. So I'm going to add 8 to both sides. This we covered in the 7th grade standards. It cancels on the left, leaving me just with 1y. On the right, 1 plus 8 is 9. 1y is the same thing as y. So once you have one of them, then you're good. If it makes you happier to just write y equals 9, that is perfectly fine. The last thing you should always do is plug it in and make sure it works. So let's go back up to that original equation. Instead of 7y, let's do 7 times 9. That would be 63 minus 8. On the other side, 6 times 9, that would be 54 plus 1. Both of those are going to give us 55, so I know my answer must be good. Let's try another one. I'm going to split it again so we can see a little bit better. So we have two options. We can subtract the 8y from both sides. That's going to create a negative on the right, though. I don't want to deal with that. So I'm going to subtract the 6y from both sides. If you don't mind negatives, it's fine. Just with all my years working with 7th and 8th graders, like I said, negatives is usually where the mistakes happen. So I just avoid them if possible. On the left, 8y minus 6y is 2y. I still have a minus 3 equals. Those cancel. And I have a positive 17 or just a 17. Now, when we first learned two-step equations, we talked about splitting it through the equal sign and then boxing the variable part. Again, like I said on the first problem, you've got to get rid of what's with the variable but not touching it. So get rid of what's on the same side but not in the box. I need to add 3. So now I have 2y equals 20. Not quite done because I don't want 2y. I just want y. The opposite of multiplying by 2 is dividing by 2. And that leaves me with y equals 10. Let's make sure that works. Let's go back up to the original equation and plug 10 in for y. 8 times y would be 8 times 10. That's 80 minus 3. So that gives me 77. Over here, 6 times y would be 6 times 10. That's 60 plus 17. That also gives me 77. It's good to go. Okay. Let's try another one. If I can get my stylus to work. I'm going to split it. Now, on this one, I really don't have two options. Because if I subtract the 2n, what happens is, here, just watch. If you are writing these along with me as you're learning them, don't write this down. Just look for a second. If I subtract the 2n so that I avoid negatives, which I can, I'm going to get 3n plus 9, but then what? Oh, there's nothing over there. So I'm going to have to put 0. And now I'm going to have to subtract 9. And then I get 3n equals negative 9. Divide by 3. And I get n equals negative 3. So that's fine. It's a bit more work than I want to do, though. It's no more work than the problems I did on the page before this, but the reason why I'm saying that is there's a shortcut on this. Since if I take away the 2n, I end up with a 0, let's not do that. Let's instead go back to that original problem, the 5n plus 9 equals 2n. Let's subtract the 5n. I only have that one constant, the 9. So I'm not going to have to get my constants together. That's already done. There's only one thing there. So I'm going to subtract the 5n so that that drops on the left, and I just have positive 9 equals negative 3n. Divide by negative 3, and look at that. We're already there at our answer. Negative 3 equals n. So they both work. But if I can avoid extra steps, I'm probably going to try to avoid extra steps, right? Okay, let's look at the next one. Now, I could subtract the 11x, but then that leaves me with nothing over there. So let's not do that. Let's get rid of the 8x. That way I still have something on both sides of the equals. So on the left, 11x minus 8x, that's 3x. Oh, here it goes, not wanting to write. There we go. Equals, on the right side, I still have a 24. Opposite of multiplying by 3 is dividing by 3. So I end up with x equals 8. Let's make sure that works. I didn't do that on the last one. So I'm going to go back up to my original problem. Instead of x, I'm going to put in 8. So that would be 11 times 8 is 88. And 24 plus 8 times 8 is 64. Whoops, I wrote an equal sign. 64 and 24, yeah, that's 88. We're good. So I know my answer's right. I would encourage you to always plug it in and make sure it works. Moving forward, I'm not going to plug every single one in. Now that you've seen a refresher of how to plug it in and check it, I'm going to leave that to something that you could do on your own. And we're just going to keep pushing through how to solve these. Okay? So I'm going to split through the equal sign. Now I have a variable on each side, so I have two options. I can subtract the 5p or I can subtract the 4p. I'm going to subtract the 4p. That way I don't get a negative, but if you do, it's not anything big. So on the left, I have 1p plus 2 equals, that cancels out, and I get a negative 1. I need to get rid of the plus 2, so I'm going to subtract 2. And that gives me 1p equals negative 3. 1p is the same thing as p, so p equals negative 3. Okay. So I have 4 problems here that I would like for you to try. What I would encourage you to do is hit pause on the video, get your 4 answers, and then resume play and see if you match mine. Okay. Hopefully you did. I hope that you really did pause and try this, but let's go over them. Number 1, I'm going to split it. Subtracting the 2g doesn't really get me anywhere because then I have nothing over there and I've got to add a 0 and create a whole extra step. So I'm going to subtract the 9g from each side. Now I have a negative 14 equals negative 7g. The opposite of multiplying by negative 7 is dividing by negative 7, because remember, the ultimate goal is to get g by itself. So I've got to do the opposite of multiplying by negative 7. And I end up with positive 2 equals g. Did you get that? Let's see how you did on number 2. I'm going to split it. Okay, so I have two options. I can move the negative 6f by adding 6f to each side, or I can remove the 2f by subtracting 2f. Like I keep saying, I avoid negatives if I can. So I'm going to add this 6f. That way I don't have negatives anymore. So on the left, those cancel, and I have a positive 13. Oh, come on. Equals 2f plus 6f is 8f minus 11. Now I have to get rid of what's with the variable, but not directly touching it. So I've got to get rid of that minus 11. The opposite of subtracting 11 is adding 11. So I'm going to do that to both sides to keep it balanced. So now I have 24 equals 8f. The opposite of multiplying by 8 is dividing by 8. So I end up with 3 equals f. Number 3, I see a decimal, but we don't need to freak out. We're fine. I can get rid of the 4h, but that creates where I've got to put a 0 and blah. So I'm going to subtract the 2.5h from each side. So on the left, that cancels. I have a negative 15 still, equals 4 minus 2.5 is 1.5, so 1.5h. The opposite of multiplying by 1.5 is dividing by 1.5. So on the right side, that cancels, and I just have my h. On the left, my signs are different, so it's going to be negative. If you take 15 divided by 1.5, you get 10. So h must be negative 10. Last one of these, I'm going to split it again. I can either subtract the 2z or I can add 9z. I'm going to add 9z back in. Why? Because I don't like negatives. So on the left, now I have 11z minus 31 equals, that cancels, and I still have a positive 24. I've got to get rid of the minus 31. The opposite of subtracting is adding, so I'm going to add 31 to both sides. And now I have 11z equals 55. Opposite of multiplying by 11 is dividing by 11. So I end up with z equals 5. Okay. A couple more things I want to show you. Problems like this are really pretty common. They want you to find the value of x so that the perimeters of the two shapes are the same. How do you find perimeter? Do you remember? Perimeter is when you add up all the sides. So let's look at our triangle. If I add all those up, let's do the x's first. X, 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 that's 3x. Now let's look at our constants. Plus 4, plus 5, plus 2, that's a plus 11. So the perimeter of the triangle I can represent by 3x plus 11. Let's look at the rectangle. First of all, I've got 4 sides. I only see 2 of them listed. So I'm going to go ahead and write down that this one matches the x plus 3 and this one matches the x plus 1. Okay, x is first. X, 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 x. That's 4 x's. Constants, 1, 3, 1, 3. That's a positive 8. So the perimeter of my rectangle is 4x plus 8. I want them to have the same perimeter, so I'm just going to put an equal sign in between. And now it's exactly what we were doing on all the problems before this. I'm going to split it. I can subtract the 3x, or I can subtract the 4x. I'm going to subtract the 3x. Guess why? Because I don't want negatives. So the 3x disappears over here, and I have positive 11 equals 1x plus 8. The opposite of adding 8 is subtracting 8. You always want to get rid of what's with the variable but not touching it. That's why I was getting rid of the 8 and not the 11. 11 minus 8 is 3 equals 1x. 1x is the same thing as x. So x has to be 3 for those perimeters to match. Okay, your turn. If I want those two polygons to have the same perimeter, figure out what x would have to equal. Hit pause on the video, give it a shot, and then hit play, and we'll see if we get the same answer. Okay, so the first one is a pentagon. I have 5 sides, and they all equal 12x. 5 times 12 is 60. So that is the same thing as 60x. On my triangle, let's see x's. I have x, x, and 6x. That's 8 of them. And on my constants, I have 7, 9, and 10. That's a 26. I want these to be the same, so I'm going to put an equal sign in between. Now, to get my x's together, subtracting 60x isn't going to help anything. So I'm going to subtract 8x. On the left, that gives me 52x equals 26. Now, be careful on this. You have to get rid of the number that's with the variable. It's not the 26 I've got to get rid of, it's the 52. So I'm going to divide both sides by 52. So I get x equals, I have a feeling that several of you might have gotten 2 for your answer. But we're not doing 52 divided by 26. 26 divided by 52, look at it, it's a fraction. 26 over 52 is the same thing as a half. Or when you divide, you get 0.5. For this to work, x has to be a half. If you got 2, don't be too hard on yourself. That means you got the meat of the problem. You just missed the very last step. So super close. Okay, I want to do 2 word problems and then we'll be all done with this lesson. I want to write and solve an equation for this. Company A charges $40 a day plus 25 cents per mile to rent a car. I'm going to write that down. I don't want to have to reread this 50 billion times, so I'm going to go ahead and write that down. $40 a day plus 25 cents per mile. Well, wait a minute. Are we going to need to use a variable for the day or for the mile? Maybe I better keep reading a little. Company B charges $25 a day, okay, plus 45 cents per mile. 45 cents per mile. But again, which is my variable? Which is the one that's going to change, that's going to help me get my answer, the day or the mile? Let's keep reading. What number of miles? There it is, right there. I'm trying to find miles. So let's define a variable. Let's say that we're going to use M for miles. And we're just doing this for one day. So that means on the first company, the 40 is just 40. It's just for one day. Plus 25 cents times every mile. So I'm just going to put a little M beside it. Second company is 25 plus 45 cents per mile. So put a little M beside the 45 cents. I want these to be equal. So there's my equation. So now to solve this guy, we've got to get the variables together. Let's subtract the 0.25 M. So that gives me 40. That goes away. Equals 25 plus 0.20 times M. So now I've got to subtract the 25. And that gives me 15 equals 0.20 times M. So how do we solve this guy? With my variable, the opposite of multiplying is dividing by 0.20. So I'm going to divide both sides by 0.20. We can figure this out. There's, let's see, you would need 20 times 5 to make $1, right? And you need $15. So 5 times 15, it's going to be 75. But we can even double check it. 15 divided by 0.20, 75 miles. Okay, last problem, and once again, I would encourage you to try this one. I think it would be a really good thing for you if you hit pause and you try it, and then hit play and see if we got the same answer. Okay, so there are two options for buying tickets to local minor league baseball games. Option one, one-time membership fee of $30, and then a ticket price of $3. So $30 for the day plus $3. Like the last one, I'm not sure which is for the variable yet, so I'm going to wait. Option two, no membership fee. So you can write a 0 if you want, or you don't have to write anything, plus $6 for the tickets. For how many tickets? There it is. Okay, so T is for tickets. I'm going to define my variable. So that means the membership fee is going to stay 30 plus 3 times T. The other one is 0 for the membership fee plus 6 times T. And we want those to be equal. Okay, variables together. I'm going to subtract the 3T. Whoops, didn't mean to write 36. No, that's sloppy. The reason why I'm doing this, it'll help you see it a little bit better. I said you could put the 0 or you don't have to. Well, look, if we don't put it, we don't want to subtract that 6T or we end up with nothing over there. And then you've got a random 0 and you've got to deal with all that. So why mess with it? Let's just subtract our 3T. So now I have 30 equals 3T. Opposite of multiplying by 3 is dividing by 3. So that gives me 10 equals T. It's going to take 10 tickets for those two deals to end up being equal. Okay, I hope that helped. This was 8th grade standards, but like I've said before, I am a 7th grade teacher. I use the 8th grade standards with my advanced class. Typically with 7th grade, you don't get into the multi-step equations or variables on each side, but advanced class or GT classes, you would. If you need any more help with 7th grade standards or a handful of 8th grade standards, feel free to check out my YouTube channel, Math with Luger. You can subscribe, and there's plenty of videos there that'll help you. I know they're not Oscar worthy, but it's just like being in my class. They'll hopefully help. My students, parents of my students, you know how to get a hold of me. Please reach out if you have any questions. I hope you found something useful in this. And as always, thank you for sticking around to the end and tuning in. Until next time, bye.